Hello everyone, welcome to the signal system class. In this video, we will discuss how to find out the exponential form of the Fourier series expansion for a given periodic wave. We have taken an example in which we have to find out the exponential form of the Fourier series expansion for the periodic rectangular pulse train which has been shown in the figure 1. So, in order to find out the exponential form of the Fourier series expansion for any wave, we have to write the expression for f t in one period, that is for t lying between minus t by 2 to plus t by 2. So, for the given periodic rectangular pulse train, we find that the expression for f t will be given by f t will be equal to 0 when t lies between minus t by 2 to 0. Similarly, f t is equal to a when t lies between 0 to t p, and f t is again equal to 0 when t lies between t p to t by 2. Once we have written the expression for f t, we will substitute the value of f t in the expression for alpha n. We know that the expression for alpha n is given by 1 by t integration from minus t by 2 to plus t by 2 of f t e to the power minus j n omega t into dt. So, we have substituted the value of f t in this expression. So, now the limit will change from 0 to t p because the value lies only in the interval from 0 to t p. So, once we integrate this equation, we get the value as shown here. On solving this equation, we get the value of alpha n is equal to a by j n 2 pi e to the power minus j n pi t p by t, then e to the power j n pi t p by t minus e to the power minus j n pi t p by t. Now, we know that e to the power j n pi t p by t minus e to the power minus j n pi t p by t divided by 2j is equal to sin n pi t p by t. So, we have substituted the value in this equation and we get the expression of for alpha n is equal to as shown here, and let this be equation number 1. Now, we will substitute it in the expression for the exponential form of the Fourier series, which is given by this expression. Once we substitute the value of alpha n from here to this equation, then we get the value of the Fourier series expansion as shown here. So, this is the required Fourier series expansion of this given periodic rectangular wave. Also, we find that the given function has no symmetry conditions. So, the trigonometric form of its Fourier series expansion will contain both the cosine and sine terms for all the values of n. Now, suppose we want to find out the frequency spectrum of the given periodic rectangular pulse train. So, we need to know what is frequency spectrum. The frequency spectrum for any wave is a plot of the amplitude 2 times of alpha n versus n omega. So, we will find out the value of 2 times of magnitude of alpha n, which is given by this expression. We will substitute the value of magnitude of alpha n and we will find out the value of n omega. We know that omega is 2 pi by t. So, we will substitute this value and we will get this n omega is equal to 2 pi n by t. Now, if we substitute the value of n is equal to 0, then we find that the equation 1 becomes indeterminate, but this equation can be easily evaluated by applying L'Hospital's rule. So, by applying L'Hospital's rule, we will get the value of alpha 0 is equal to a t p by t. So, this is the average value of the given function. Now, we have plotted the frequency spectrum in the given figure, for which we have taken the value of t p by t is equal to 1 by 6. So, by substituting the value of t p by t is equal to 1 by 6, we have calculated the value of alpha n or 2 times of magnitude of alpha n for various values of n, that is for n is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and we get the values as shown in this table. We will get the values of 2 times of magnitude of alpha n, that is we will get the amplitude as shown in this table for various values of n. After obtaining the values of the amplitude, we will plot it in a graph paper. Here we have shown the frequency spectrum for the given wave ft, in which we have taken a plot of the amplitude versus n omega, that is the plot of 2 times of magnitude of alpha n versus n omega, and we have plotted all the values of 2 times of alpha n for the values of n is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The plot will come as shown in this figure. We will join all the tip of all the lines, and so in this way we can obtain the frequency spectrum of any given wave. In this way we can find out the frequency spectrum, and we can also find out the exponential form of the Fourier series expansion of any given wave. Hope this topic is clear to all of you, and you will be able to find out the frequency spectrum and the exponential form of the Fourier series expansion of any given periodic wave.